In this lesson, we're going to find out how to write the equation of regression lines. And what that is you may go out and collect a lot of data and then you plot that on a graph. It would look like a scatter plot. And then you want to draw a line through those points and come up with a line that predicts what will happen in the future. And that's what a regression line is. So what we're going to do is we're going to say you go out and you collect data in some sort of an XY point form. So you're only going to have two variables, say X and Y. You can label them whatever you want, but there's just two of them. And you're going to approximate a linear equation for that data. Okay, like I said before, you're only going to have two variables, so it can fit on a standard XY graph. You're going to plot all those data points on one graph. That would be called a scatter plot. You don't want to connect any of the points together. You're just going to leave those at points. And sometimes you may have duplicate X or duplicate Y values. You may have a data point that may have the same X or it may have the same Y's. And also another thing about that graph is you really don't have to have the X and Y axes have the same scales. It may turn out that the Y-axis may be in thousands and the X-axis may be in tens. That really doesn't matter. So after you've plotted all your data, the next step is you're going to draw a straight line through all the points. Now, what you're going to try to do is you're going to try to minimize, obviously, that line is not going to be able to touch all the points because it's a straight line, but you want to minimize the distance between the points in that line. So you're going to try to fit the line to all those data points. Once you get that done, that line is called the regression line. After you get that regression line, the next step is you want to actually find the equation of that regression line. Now, in a previous lesson, you learned how to find the equation of a line by using, say, the point slope form. So as long as you can find 2 points on that line, you can come up with an equation for that line. Now, one thing you want to do is you definitely want to make sure that the lines are fairly far apart. That would help reduce the accuracy. So make the 2 points that you're picking fairly far apart. And this whole thing is going to be called approximating a best fit line. So when it says approximate, that doesn't mean you just draw the line. That means you also have to come up with the equation of a line. And like I said before, we're going to use point slope to actually write the equation, and then at the end we'll move it into slope intercept form. Okay, so let's go ahead and start an example. So what we have here is we have some sort of data that we were asked to get, and so we can see that the X values are all in a row and the Y values are all in a row. So the first step would be to plot those points. So I'm going to go ahead and plot them, and when I do that, I'm actually going to pause this because that's going to be kind of tedious, and you all know how to plot points, so you don't need to see me do that. So I'm going to put it on hold for a second. Actually, I am going to plot just a couple points so you can see how this is done. You can see that my X values are small. They only go between, say, 0 and 20, while my Y values go all the way up to 1,650. So this is a case where I need different scales. Notice my Y-axis has much larger values than my X, and that's okay. It's not going to matter when I'm done. So for example, I wanted to plot the first point, 4, 150. I would come over 4 in the X direction, then I would move up to 150 in the Y. So that point would be right about there. Then let's take a look at the point 7, 450. So I move over to 7 on the X. I'd go up to 400 and plot 450 right there. So I'm going to continue doing this on my own, and then I'll turn it back on. As you can see, I plotted all the points now on the graph, and the next step after I plot the lines was to draw a straight line through the points. And the idea here is to try to get as many points as possible that fall on the line, try to get an equal number on either side where the distance between each particular point in the line is about as small as possible. So to me, that was about the best line I could draw. It took me several chances on this tablet PC. When you touch the screen, sometimes it jumps around. So I wanted to do it offline. Anyway, you can see that that's my best fit line. That's what I came up with. Now, once I draw this best fit line, I'm going to try to find the equation of that line. And I'm not going to use my points anymore. So what I need to do is pick some points on the line itself, not points that are off of it. And I want to pick some points that are fairly far apart so I get good accuracy. So let me just try to find a couple points that are actually on the line that I want to use. And we can see that this, maybe this point right here, we can see it's crossing a grid point. So that maybe is a good one to use right there. It looks like that would be 18, 19, that's 20. And the y value would be 1700. And let's pick some other point on the line that looks like it crosses through a grid. And we got kind of lucky here that this one looks like it's going to cross this point right here. And so that point looks maybe to be 2, 0. So now I have my 2 points. So what I can do is use the point slope formula and come up with the equation of that line. Then I could use that to predict any value that I want. So let's see how that works. So here's my equation. So I'm going to have the point we said is those 2 data points. So let's find the slope. And the slope is going to be the difference of the y's, which would be 1700 minus 0 all over 20 minus 2. So that's going to be 1700 all over 18, and we can use a calculator for this. And what I've got is I got the slope is about 94.4. So let's plug that into my equation for point slope form. Y minus y1 is equal to the slope x minus x1. Now I can use any point that I want that's on the line itself. So why not use one that's easy to use? I'm going to use the point 2, 0 because that is on that line. And so let's go ahead and plug that in. So we've got y minus 0 is equal to the slope of 94.4 times x minus 2. Y is equal to 94.4x minus 188.8. So that's my regression line, and that would be called approximating the line for that set of data. One more thing we could do is, let's say that the question said, okay, figure out what the value would be if x would be 30. Now you can see that x equals 30 is not on my graph, but now that I have the equation, I can figure that out. So I would plug it in. Y is equal to 94.4 times the 30 that I'm filling in for x minus 188.8. So I've got 2,832 minus 188.8. And so I get 2,643.2. And that's how then I can use this equation of the line to model some future value. The last thing I wanted to cover in this lecture is just the different types of correlations we may see when we do our regression lines. And what we have in this first one here is a positive correlation. So what we can see is that if we would draw a line through that data, kind of like that we could see that as the x gets larger, the y value is also getting larger, right? As we move upward on that line, that would be a positive correlation. In the second one, we have a correlation that is moving in the opposite direction. So we could see that as the x value goes out this way, it's getting larger, but as we go down this line this way, the y value is getting smaller. So that would be negative correlation. And in the last one, there's really no pattern at all. I would not be able to draw any line through there. Any line that I draw would just be a guess. So that would be a no correlation.